Today, we're going to learn how to find the area of a right triangle. And remember, a right triangle is simply a triangle that has exactly one right angle. Now, we're going to use what we know about the area of rectangles to help us develop a formula for the area of a right triangle. And we're going to use this rectangle to start. If you look at this large rectangle, you'll see that there are smaller squares within that rectangle. Each of those smaller squares is 1 square inch. So in a minute, I'm going to ask you to pause the video and answer the following question. What is the area of this large rectangle in square inches? In other words, how many square inches fit inside of this rectangle? Pause the video and figure it out. If you said the area was 20 square inches, you got it. Nice job. There are a number of ways to see this. First of all, we can simply count them or use a faster strategy to count. There are 1, 2, 3, 4, 5 square inches in each row, and there are 4 rows. So 5 times 4 is 20. This leads us to a well-known area formula for you guys. That's the area formula for a rectangle. Sometimes it's stated as length times width. Other times it's stated as base times height. But either way, it involves finding the length of one of the sides, called the base or the length, and finding the height or the width and multiplying the two numbers together. In this case, the base is 1, 2, 3, 4, 5 units long, and the height is 1, 2, 3, 4 units high, and 5 times 4 is equal to 20 square units. In this case, square inches. So what does this have to do with right triangles? Well, you've probably noticed from the beginning that I have a pretty obvious diagonal line cutting across the rectangle. And this leads to an important fact. Every single rectangle in existence can be thought of as actually 2 right triangles stuck together. Notice how this diagonal line cuts the rectangle directly in half. If I remove one of the halves, I'm left with a right triangle. And notice that this right triangle has the exact same base length, 5, and height, 4, as the original rectangle. Now here's where you got to do a little bit of thinking. You remember that the area of the rectangle was 20 square inches. We've cut the rectangle in half and removed one of the halves, leaving a right triangle. What's the area of the resulting triangle? Pause the video and think about it. If you said the area gets changed to 10 square inches, you got it. It's half of what it originally was. It used to be 20, but we've removed half of the area, resulting in 10 square inches. And notice this would be true of any rectangle. If we cut it across the diagonal and removed half, the area gets cut in half, and we're left with a right triangle that has the same base and height as the original rectangle. This leads to the formula for the area of any right triangle. It's very similar to the rectangle formula, base times height, but it's not base times height, it's half of the base times the height. So we put a 1/2 out in front. So it's the same area as the original rectangle, base times height, but we multiply it by 1/2 to cut it in half. And now we've got a trusty new formula that we can use for any right triangle. So let's use this formula to find the area of this right triangle, which we already know is 10. The base length is 5, so we'll put that in for the b. Rewrite everything. Area equals 1/2 times 5, and the height is 4 times 4. Now working left to right, 1/2 times 5 is 2.5. So I get area equals 2.5 times 4, and 2.5 times 4 is 10. And we get the same answer. So there you have it. Today we're learning how to use the area of a right triangle formula, which is the same as the rectangle, simply cut in half. Have fun!